So I'm here to talk about a particular kind of interactivity, and in particular about the tools that we've spent a very long time developing to enable authors of technical documents, things like textbooks, scientific publications, engineering documents, to enable them to create deeply interactive content that effectively communicates the sorts of difficult ideas that these technical documents have. What I mean by computational interactivity is the interactivity where the important part, the thing that really makes it interesting, isn't flashy graphics or clever ways of using touch interfaces. It's the underlying mathematical models, simulations, data, things like that. And creating this kind of deeply interactive mathematical content is very hard. It requires the participation of a subject matter expert, somebody who really knows the topic, who knows the math, understands the ideas to be communicated, and who can implement those ideas in some kind of a computational system that they're familiar with. And then it usually also requires a whole different group of people, sort of programmer types who understand things like HTML5 or Flash or JavaScript, completely different programming environments in order to take the mathematical models that the subject matter expert has developed and turn them into actual interactives that you can deploy on the web or wherever you want to deploy them. So I've been involved for a very long time in trying to create tools for people who work with computation in their professions. And I've also been involved in trying to create tools for electronic publishing for about the same length of time. I started off developing the Mathematica notebook interface as a way to create documents that mix text and graphics and computation and later dynamic interactivity in an integrated way. And at the same time, I was trying to write books and other things to, that were interactive electronic documents. And back in the sort of early and mid 90s, the world wasn't really ready for that kind of thing yet. It seemed obvious to those of us working on the tools that one ought to be doing all scientific publishing, for example, in electronic form with interactive documents, but the world wasn't ready yet. And so we concentrated on developing tools for people who did math rather than tools for publishing interactive content. But the world has now kind of changed, and our response to this is to tailor our technology. And so we, at this same conference last year, we introduced a technology we call CDF, the Computable Document Format. And we promised that we were going to be releasing it, and we did over the summer. And it's now being used by more and more publishers and platforms. But this CDF technology, although it was only announced a year ago, is based on 24 years or so of work in this area. And let me show you a little bit of what this can do. If we can switch to the demo machine. I'm going to assume that you're now seeing a thing that says Calculus Early Transcendentals. It's sort of disconcerting not being able to actually see, because it's not there either, by the way. Anyway, so this is, there we go. So this is the Briggs-Cochrane calculus textbook. At the time that I showed this actually last year, and if you go through this, you'll see lots and lots of interactive diagrams. And you can just keep going. There's just more and more of these. These are all 2D graphs, but there's other chapters where there's complicated 3D graphs and things you can rotate, and there's just all kinds of things you can do with it. And what's relevant about this is, at the time that this book was introduced, it was not one of the big, huge calculus juggernauts with millions of dollar, huge $1 million budgets. It was a new, unproven book, and the budget for generating interactivity was a guy, a community college professor in Washington State who is an expert in Eric Schultz. He's a very competent calculus educator, but he's not a programmer. He's a subject matter expert. And yet he was able to create over 600 nice interactive diagrams like this using the CDF authoring environment. Let's see, we're not switching back yet. Yeah, so this is an illustration of what sort of the fundamental advantage that this way of looking at interactivity has, the CDF system has, which is that it's radically cheaper to produce large amounts of high-grade, complicated interactivity. You can do it with just a person or two who is an expert in the subject, not a team of programmers. And because it's radically easier and radically cheaper to do, you can do it for a much wider range of publications, like maybe all publications at some point. Anything that has this kind of content in it, it ought to be interactive. OK, if we can now switch back to the talk. Do you see something that said CDF is spreading? Good. OK, so I just showed it to you, an example of a textbook. And this, by the way, although a year ago it was an unproven book, this book is now, it was Pearson's Product of the Year, and it is a highly successful book. We like to think, in large part, because of its interactive electronic version. And that's a technology that's been considered very successful at Pearson and is now spreading there. This is delivered through the Pearson MyMathLab online courseware system. So it's essentially a cloud distributed thing. It could perfectly well also be distributed as a desktop, files that you would copy. It could be deployed as a browser plugin. So CDF is kind of spreading this textbook. You can find it in blogs. These are a couple examples of blogs that have embedded CDF interactive elements that explore various interesting computational things. We have a plugin for WordPress that makes this particularly easy. This is our user-generated content site, demonstrations.wolfram.com. It has thousands and thousands of user-submitted interactive widgets or applets or whatever you want to call them. This is a courseware resource site that we maintain that has complete textbooks in CDF format with lots of interactive diagrams in it. All of this is possible, not so much that you couldn't do it in principle using some other technology, but you just wouldn't because it would be too hard and too expensive to do. So rather than just assert its easiness, let me actually show you how you might go about doing it. A sort of creating deep computational interactivity for dummies demo. And we have several levels of authoring environment for this. So if we could switch back to the demo machine now. If you see a big slide that says switch to demo machine, that means they didn't do it yet. So I'm going to show you first the most hardcore, low-level way of doing this, which is the Mathematica notebook environment. Let's make a simple command, plot sine x, x from 0 to 2 pi. So this is a very simple plot, but you have to imagine that this is actually something really complicated involving math. Maybe it's a model of Greek debt or something like that. And we're just using this as a stand-in, as a simple example. But this is the sort of irreducible subject matter complexity that somebody who knows the topic has done. And they've done it in Mathematica because that's the system that lots of people who do that kind of work use. It's a very comfortable environment for doing this sort of mathematical modeling. Now, to make it interactive, we need to add a parameter. So rather than just saying a single plot, let's make it a plot and put in a parameter n and let that run from 1 to 10. So now we have a little bit of a computational space that we have here. We've explored what happens if you vary that parameter. Let's copy. Now, supposing now we want to make this into an interactive where we have a slider connected to n, and we want to see the effects of that interactively. So you do that. The hardest part of this actually is spelling manipulate properly. OK, so now we have an interactive version of this plot. And that's it. We're done. I mean, this is a CDF interactive widget. If we wanted to put this on the web somewhere, we would go to the deploy command. We can deploy it as a standalone CDF. We can embed it in an HTML document. The step from here to here is where you usually hire the team of programmers who need to redo this, right? The character count it's 5 extra letters here. And it's not so much that the whole problem is trivial, but the adding of the interactivity, the extra step beyond the content to the interactivity, is what CDF makes radically easier. But you can actually go a step farther if you don't really want to use a language like a mathematical language, we actually have a thing called Wolfram Alpha, which unfortunately I forgot to log in here. Let's see if I'm still logged in. No, I'm not. OK, so I'm going to sign into the new Wolfram Alpha Pro service, which we actually just launched yesterday. Oh, good, it remembered me. OK, and let's say we want to vary the parameter n in a plot of sine. Let's do something a little more interesting. Let's say xy to the n power. So Wolfram Alpha, if you're not familiar with it, is a natural language computation system. It's not a search engine, although it looks a little bit like one. And it takes queries of free-form natural language input and gives you results. And with Wolfram Alpha Pro, it sometimes, depending on what you ask, gives you results that include, as their output, as their generated output, interactive CDF objects. So we have here a thing with a slider that we can move around. And the exact nature of what kind of interactivity it produced, how many sliders, what layout, what the content is generated from the natural language query. And this is something which you can now take. There's little pop-up things here. You can take that module, publish it as a CDF document, embed it into your own web page, publish it to your blog, do all the sorts of things that you might do with an applet or an HTML5 widget or whatever. Those of you who are veterans of software demonstrations may be wondering the same thing that I would be in this situation, which is, well, that's all very nice, but what exactly is the range? What is the scope of interactivity that a natural language system like this can actually produce? Is it actually flexible enough to be useful in producing meaningfully different and original interactive content? And there's fundamentally two answers to that question. One is Wolfram Alpha is a very broad system, a very powerful system, and it does a lot on its own. The other answer is that you're not stuck in it. If we go here, here we go. Copyable plain text. We can take this, copy it, and paste it back into Mathematica and evaluate it. We have it here. And we now have it in a computer language. We've been taught how to do it by the natural language input system, but we're now free to go in here and mess with it and change the parameters and have it do something else. And that's where the real power lies. The Wolfram Alpha system is sort of like, it's power-assisted programming. It gets you started. But then you have the full power of the language underneath it. OK, so let's go back here, because we are rather short on time, I believe. OK, so you're seeing something that says CDF authoring environment? Very good. OK, so CDF represents essentially a complete ecosystem. We have a couple levels of authoring environment in which you can create these interactives, and we have a variety of deployment environments in which you can publish your content, desktop distribution, web, online distribution, cloud distribution of various kinds. The one thing I haven't actually mentioned is the thing that's actually in the title of my talk, which is, of course, mobile deployment of this, for example, on an iPad. So if we could now switch to the iPad. Are we seeing the iPad? Very good. So theoretically, OK. So this is the CDF player, which is another name for the complete Mathematica computational system, all of its ability to implement underlying mathematical models running natively on an iPad. If I click one of these things, I get some controls. I can move the thing around. I can touch different buttons. If you're familiar with the size and complexity of what Mathematica can do, we're rather proud of the fact that we actually got this to run on an iPad. We're not announcing this. It's not shipping today. We're not announcing a release date. But you saw it with your own eyes. It works. It is a complete CDF player running on an iPad. And we see this as a pretty important, relatively near-term expansion of the sphere in which CDF can be deployed, or the set of places you can see it. So if we can go back now to the talk notebook, that's what I had to say. Thank you very much. And if you're interested in this, if this is something that you as a publisher or an author or anything like that are interested in, these are the relevant places and the relevant people to talk to. And we'd very much like to talk to you about using this technology in your publications. Thank you.